Hey folks, this week I talk with Alexandre Dulaunoy and Quentin Jérôme about Kunai, which is an open source Linux threat monitoring tool, and CIRCL, which is the computer incident response group out of Luxembourg. It's a really fascinating conversation about the tool and also what all CIRCL is up to, and some talk about where the threat landscape for Linux is these days. It's a lot of fun. You don't want to miss it. This is FLOSS Weekly, episode 832, recorded Tuesday, May the 6th. Give yourself a medal. It's time for FLOSS Weekly. That's the show about free, libre, and open source software. I'm your host, Jonathan Bennett, and we've got something very fun today. We're talking about, well, Linux, not to any great surprise for those that know me, but Linux security. Again, not a great surprise. It's something I care a lot about. We're going to be talking with Quentin Jérôme and Alex Dulaunoy about, well, a couple of things. The Kunai project and then CIRCL, C-I-R-C-L in general, which is all about security. Linux security in particular, but lots of security things, trying to keep computers safe. It's going to be really interesting, and I am going to get to learn a lot about these projects as well, because I don't know a whole lot about them yet. We don't have a co-host today. That is fine. Again, it's on me. I just putting things together at the last minute. I was sometimes the do your homework on the bus on the way to school type, and it shows every once in a while. But that's all right. We're going to have fun today. So we're going to go ahead and bring them on. And so first off, Quentin and Alex, welcome to the show. Thank you so much for being here.
Welcome. Thank you.
It's good to have you both. So I know one of you is sort of representing Kunai, and the other is sort of representing CIRCL. Which is which?
So I'm representing Kunai.
And I'm representing CIRCL, yeah.
Okay.
Even if Quentin is working at CIRCL.
That's how that tends to go sometimes. Yeah, and that's fine. So what is Kunai? Why would somebody use it? And what's the problem it's trying to solve?
So yeah, it's a problem that showed up recently with the limitation that actually people are seeing with traditional antivirus, for instance, and basically the need to have security visibility on their operating system. So there are not like a lot of free tools for doing this. On Windows, there was this Sysmon project that has been kicked off by I don't remember, Mark Ruzinovich, like a while ago. And basically, they announced some time ago a Linux version. I don't remember exactly, maybe 4 years ago, something like this. And I was basically waiting for this for a very long time. And when the project came out, it was super weird because couple of weeks after, the main developer left Microsoft, and I was also very disappointed by that project because they took a lot of ideas from Sysmon, which was really, really great, but they, in my opinion, didn't adapt it properly to the Linux world. And that's basically how I decided to start developing Kunai. It is basically to have the Sysmon equivalent on Linux, and it brings a lot of visibility on the Linux hosts, and a bit more than what currently exists, like ODD and so on. So probably you can do some stuff that Kunai does with ODD, but it's going to be really, really hard to do it. And it's really focused on security visibility and basically threat hunting and threat monitoring, basically on the host. It's not for monitoring performance. It's not for diagnosing syscalls or things like that. It's really focused on threat hunting, threat monitoring, and all these let's say, sphere.
And Alexandre, what is CIRCL, and how does that fit into this?
Well, that's a long story, but CIRCL is like US CERT. So we are the national CIRT in Luxembourg. So we do incident response, but we have a small particularities compared to other CIRT worldwide. We do open source. From the early beginning of the CIRT, we decided to do open source. We maintain and manage 17 open source projects. Maybe the most well-known one is MISP, which is a trade intelligence platform that you might know. And we do other open source projects. But from the early beginning of setting up the CERT and giving services to citizen organizations and members in Luxembourg, we decided from the early beginning to go open source. And why? The reason is very simple. We are funded by the state and it's public money. So we decided this must be public code. And for us, it's I would say, kind of DNA of the CERT CIRCL. So we do incident response, but next to that, we do software engineering and software development, which are open source projects. And over the times, we did additional tools and so on. And then we were missing EDR or threat hunting platforms for Linux. And then Quentin joined the team to work on this and to have a complete open source solutions for threat hunting on Linux kernel.
Interesting. So let's dive into Kunai just a little bit first. And I'm really curious. Like what? So obviously it's for threat hunting, but there's a lot of things that could sort of fall under that sort of category. What are the techniques that Kunai uses to try to find something on a Linux system? So are we hashing binaries on the disk and comparing them to known good values? Are we, investigating what's running in memory? Is it all of the above? Is it trying to be sort of a do all the things, all the bells and whistles antivirus? Where does it fit?
So the idea is really to give actionable data to the person actually wanting to use Kunai. So it's really exposing the maximum of information we can so that people can actually customize their detection. They can create their own detection rule based on IOC, so IOC's indicator of compromise. This is usually something which is shared across people who got infected, maybe through MISP, like the platform Alex just mentioned before, or from various sources, open source intelligence, for instance, or things like that. And basically, people can, let's say, bend Kunai to their needs. So that's where it differs from all the other antivirus, where basically you have a black box and you cannot do much with it. And for what it does, of course, it hashes binaries, not much memory investigation, but I mean, all this is a matter of implementing features. So if people are asking for this kind of features, maybe I can implement those.
And so I've done some research into this sort of thing. I'm trying to remember the name of it. There was another sort of old school open source binary checker, and the main thing that it would do is it would hash binaries. It would store the binary hashes on the disk, and then it would come back later and do the same thing and compare the two. I wish I could remember the name of that project, but it always seems with that one, with what's that?
LeadIDS or Leads or AIDS.
That might have been it.
There are many of them.
There are several.
Several that you basically hash the binaries, keep that as a baseline, and if something deviates, then you have a new hashes, and then you basically get a pop-up and think, hey.
The thing that always confused me about those was that it was hashing the binaries on the host, storing the hashes on the host, and then hashing the binaries again on the host and doing the comparison. And it's like one of those memes where you have a president of the United States giving himself the Medal of Freedom. I did so great. It's like, yeah, of course this computer is clean. It always struck me as being a bit of a problem. Really, it's a problem of establishing trust. And doing something like Kunai, it's got to have that same problem. Is it an issue that you've thought through? Are there any solutions in Kunai or that you've thought of?
So the goal of Kunai is, okay, of course you can like run it on your host, store the logs on your host, but mainly the use case that people are going to implement is forwarding the logs directly to another log storage or something like this, where they can, of course, check later the logs. And what is also very important is, depending on the log policy they have implemented in Kunai, they can use Kunai to do some sort of incident response, because it gives like a lot of information and gives information about parent process, child process, and basically you can reconstruct all the chain of execution happening on a host, which is very valuable. And basically that's the use case. Most of the people using Kunai won't just let it run on their laptop and not doing anything with it. They will very likely forward the logs.
Mm-hmm. Is Kunai also the piece that runs on the more trusted server and does the log checking? So like once we get data from Kunai, and I know I'm going to ask about what other data sources you have, but I'm just curious about the whole tool chain. Once you get Kunai collects all this data and forwards it on somewhere, what do you do with it then? Is that part of the project as well?
Not really. Why? Because people tend to have like all this process that you are describing is kind of secret sauce of every organization. So it's very hard to provide one-fit-all solution for this. It's much more easier like to say, okay, I give you the tool. And as I said earlier, this is something you can bend in a lot of ways. And that was the original goal of it. And probably it will fit your use case, and you can very likely adapt it to what happens in the back end. I've got like several questions to talks and things like that, like why do you don't provide another format? Why do you don't provide a filtering format and so on? It's basically like everyone will come with another approach to store their logs and the information they want to keep. And this is not something I really want to go into, because it's like endless and basically doesn't bring much features to the tool. It's just like formatting. So
yeah. Is this actually something where CIRCL fits in, where you've got sort of a database of known problems and you can do comparison with, this is the hash, this is the hash that I found on my computer. Let me go, give it to CIRCL and say, is this a malicious binary that you're aware of?
Yeah, it is. And we have even a project, and like Quentin was mentioning, a lot of projects are basically plug and play and kind of module based. So that means Kunai is fit in a complete framework where you'll do, for example, thread hunting and so on. And for example, we have a project called HashLookup, which contain a huge database on all the, I would say, known binaries. So if you know the NSRL database from NIST is actually that extended with plenty of operating systems, especially Linux, because Kunai is really focusing on Linux. So that means when you have an incident and someone is providing an incident case with evidences like disk of Linux servers or some binaries and so on, we can automatically check, okay, do we know that binaries is something that is completely new? Then we can even use Kunai, because Kunai has this functionality that you can run in sandboxes. So Kunai can act as a kind of sandbox. Maybe Quentin want to talk about it later on, but the idea is if you receive a binary that is suspicious and we receive it for a specific case, then we can go through the sandbox of Kunai, do the analysis, look at all the activities from the binary. So it's like dynamic malware reversing, and you just analyze the binary. And then we can check if this one is known, and we can even check if in the traces of the binaries, if it's comparable to, I would say, one of the well-known binaries that we know, and so on. And then the plan that we have too is to actually have rules that we can even share with the community to automatically detect, I would say, bad behavior or things that are deviating from standard behaviors, I would say.
Yeah, super interesting. What about, and this is kind of a weird question, but it makes sense when you think about it. What about detecting known Windows malware? And that really, it doesn't make sense in Linux until you start thinking about a Linux file server, and then all suddenly maybe you do want to detect Windows malware. Is that sort of in scope for, I guess with Kunai, it's just a matter of you're hashing files, but with something like CIRCL? Or is this where maybe we need a plugin to be able to connect Kunai to VirusTotal and do uploads there for new files?
That could be possible.
Look at that. He's like, oh, that's an interesting idea.
yeah. To be honest, I would, instead of putting this on the hosts, I would maybe put this again on the backend side, where basically you can again do whatever you want with your data. And why? Because of course, live checking hashes on VT. To be honest, would probably be the bottleneck of Kunai, because like doing a lot of HTTP requests while you are dealing with almost real-time data, it's like super slow. So this is something I would offload to a backend, for instance, because there is no time criticality to this.
But it made me think of an idea. We talk about Windows, Linux, binaries, executions. So maybe an execution with wine within Linux, and wine is monitored through Kunai, would work too. So if you want to do active reversing, I remember some project back in the days where wine was used as a way to do Windows monitoring of binaries through Linux. Maybe now we can have Kunai monitoring wine, which is basically executing a Windows binary.
Yeah.
I don't know if it works.
Definitely an interesting idea.
After this stream, we can just make a test. I think. Yeah, that's a good idea.
Yeah. So, I am always fascinated by the way rootkits work. And a rootkit, for those that don't know, I think most everybody does, but for those that don't, a rootkit is basically malware that goes to some lengths to hide its existence. So it's trying to hide from some anti-malware software. It's trying to hide from the sysadmin. And I have read about some crazy things that rootkits will do, where they're like live patching glibc to where when they find themselves in a list of processes, they just remove themselves from that list of processes. And in some cases, these rootkits are extremely difficult to find and root out. Does Kunai have any sort of anti-rootkit technology built into it? What is, like, that's a difficult problem. What does the solution to that look like?
So I guess it depends on the type of rootkit, because there is, which is called like userland rootkits, which is basically a malicious library that you manage to inject in all the processes, and that's probably what you were mentioning. Basically, they just redefine the syscalls or the function of the libc, and they filter when it's related to the process, the malicious process, for instance. So this is like completely caught by Kunai, because that's super easy. Everything happens on userland. And something we didn't mention is that Kunai runs, all the interesting and all the events are coming from the kernel land using eBPF. So I don't know if you are comfortable with this, but it's basically the way the Linux kernel has found to allow developer to develop kernel components, but basically without all the bugs. We have a good example of what happened to CrowdStrike like 1 year ago. Yeah.
How could we forget?
This would be hard to happen in eBPF, because it comes with a nice code verification, let's say, step. So you cannot load any code in the kernel. Everything gets verified, and code is pretty safe, let's say. And so this is how Kunai works. thanks to eBPF. And maybe there are ways where Kunai could be tricked, but I don't really see how. Because if like the rootkit is a kernel module, Kunai would see it. And I'm not aware if it's like possible from another eBPF program to interfere on another. So for sure, this would be something really interesting to test. And yeah, if one of the guys in the community, one of the guys listening would be happy to try this, I mean, let's go do it. And don't hesitate to open issues after that.
Sounds like there's some really interesting sort of cases here where a security researcher that really is into Linux security could go heads down for a while and really explore all of this and see how that works. I've read about some eBPF rootkits where people are putting running malicious code inside that extended Berkeley packet filter. I must admit, I've never actually messed with BPF at this point. I know what it does. I know it exists. I've never written any code and tried to make it work there. So, I'm not as familiar with it as I could be. But I know in a couple of places there was some real trepidation about the idea of malware running BPF code. But it's really interesting that it's a good place also to run anti-malware processes. Because I guess as BPF code, like you said, it's not if there's a problem, it's not going to crash the entire kernel like someone else's module did.
No, to be honest, I'm like still wondering why malware author don't focus more on eBPF, because you can do like crazy stuff.
Yeah. Are you giving advice right now?
It's just a matter of time,
Yeah, oh, that's true.
But for sure, it's not easy to develop. So probably easier to develop a kernel module.
True. Yeah.
Right. Well, so probably what we're waiting for is for someone to release the first open source malicious eBPF example, and then all the script kiddies will copy that into their own code, and then the floodgates will be open.
I think it already exists.
Yeah, it probably does.
Something very basic.
Mm-hmm. So what sorts of things, you guys, obviously you have your pulse on sort of what's going on with malware in the Linux space. What are you seeing? And what is sort of on the cutting edge? If it's not eBPF, what's the things that people are actually doing?
I might disappoint you a bit, but a lot of malware that we see are not so interesting. And the thing is quite interesting in the fact that what kind of things they target. We recently tracked a .NET targeting only high-performance computing infrastructures. Mm-hmm. So this one is well done. We are tracking them for some months. We even exchange the C2 server on a regular basis and so on. And we were wondering why they always target HPC server, because it's a lot of investment, it's time and so on. Mm-hmm. And at the end, it's only for doing crypto mining, which is a bit disappointing. I was expecting espionage, things like that. And you end up with that. It's like, oh, guys, I mean, do better. But technically, it's nevertheless, we see some rare case, which are, I would say, more targeted, or very targeted, where it's more kernel modules or specific userland software that are well written and used for one or two targets. Mm-hmm. Some of the blog of antivirus vendors sometimes mention those ones. I think ESET mentions some of them on a regular basis. Mm-hmm. So there are some Russian threat actors, for example, that are very good at writing some exfiltration mechanism through Ethernet frames, things like that, and that are running on Linux. And so there are some interesting cases. Unfortunately, I would say, compared to Windows, the malware space on Linux is really separated into like the one doing crypto mining, the one that are doing kind of ransomware on Linux servers. Mm-hmm. So locking your servers and then you have to pay a ransom, so classical ransomware stuff. And then you have the espionage, exfiltration cases, which are, I would say, a minority. So that's 3 kind of space. And then you have all the tools for DDoS. So that's all those clients for centralized DDoS, DDoS management, collaborative DDoS, because nowadays those DDoS activities are kind of collaborative. So you have to download the client for Linux, run on a VPS, and then you get points, and those points give you back cryptocurrencies. So it's kind of thing that we have seen. So that means the kind of malware for Linux that. And Quentin did an interesting repository, which is available on a Git repository, which it takes some random samples of not always the same kind of malware, but different type of malware, run it into the sandbox with Kunai, and then we have, we don't mention that, but with Kunai, you can automatically generate with a QEMU setups, pick up the JSON files with all the activities of the malware, binaries, a nice graph too, an export for MISP and things like that. So if you want to investigate malware and so on Linux, it's a perfect tool for doing that. And then you have a complete setup. You have a sandbox repository on the Kunai project explaining how it works. It's a blog post about it, how to use it. It's super easy to do it. And if you have like suspicious binaries, or if you just want to reverse the binaries, just for example, another thing that you can use it for, it's to create rule set. So for example, you have a binaries, you have to create rules for, I don't know, AppArmor, something like that. But you can use Kunai for doing the execution and so on in the sandbox and see what are actually the binaries doing. That's a different way of maybe another way of using Kunai.
Yeah, interesting. I tend to play on the Red Hat side of the street. For me, it's all SE Linux, not AppArmor. But I could definitely see that being useful, because my usual workflow is try to run the program. Oh, it failed. Okay, let's go see which thing failed first. Okay, try to run the program again. It failed again. What's the next thing that failed? It's a very tedious way of doing it. So this sounds like a definite upgrade. Now, what about say if we had an ARM binary and we wanted to try to use Kunai to look at that, but maybe don't have an ARM machine handy? Is there some way to use Kunai with cross-platform emulation?
Yes, it is possible, because Kunai comes with, for the moment, it can compile to two architectures, so x84 64 bits and AArch64, which is like 64-bit ARM. So yeah, if you have like such a binary, you can do it. I don't provide yet other Kunai binaries to test on, let's say, older ARM architectures.
Yeah, interesting.
You can even still run ARM binaries on an Intel one using QEMU.
Yeah, makes sense.
Yeah, but we would miss like the activity, because we need to monitor the ARM kernel, and I need like a binary for this.
You need Kunai to run inside the VM, not on the outside. Would there be any way to do that, to run it? I don't even know if Linux and eBPF and the way virtual machines work right now. I don't know if that's even possible, but would it be possible to monitor from outside the VM?
Yes, this is probably possible, but I don't know exactly how it is done. And basically many sandbox platform are offering this approach, which is called like hypervisor-based sandboxing. So there is no agent on the sandbox, and they just like monitor the instructions executed by the sandbox. And you can definitely do it, but that's a completely different topic. It's
not the way Kunai is architected.
This is like for dynamic analysis, and maybe like advanced dynamic analysis.
Have you discovered yet malware that looks for the presence of Kunai?
Not yet.
Okay. It's inevitably coming, right? As the tool gets more and more popular, it's inevitable that somebody's going to write malware, and one of the things it's going to check for is, can we see if there's a Kunai instance running anywhere?
Yeah, it's probably.
Yeah, it will be a success factor, I would say.
Yes. You really there's depending upon what you're doing, there are different factors of success. So when you're running some sort of messaging platform, it's when people start using it to send spam. And I think maybe running an antivirus platform, it is, I say antivirus very, very broadly here, but it's when malware starts checking for the presence of your tool. That's when you know that you've really made it.
Yeah, I will be happy that day.
Happy and very grumpy, I'm sure. So let's see. I'm curious more about what eBPF lets you do. Again, I know very little about it. Does it basically give you all the same tools that you would get from writing a kernel module, or is it a more limited set of things that you can do to the kernel?
Yes, it's more limited. It's more limited set because you have a limited number of instructions you can execute in each probe you are loading in the kernel. Mm-hmm. So this is the first factor, and then you don't have access to all the kernel APIs. Mm-hmm. So you have to use one of the available APIs, which is exposed by the eBPF framework. And there are a lot of other limiting factors, like the fact that you cannot allocate unlimited number of memory and so on. So sometimes you really have to think a lot to write your eBPF programs. And that what I was mentioning earlier with like malware author developing malware is that you really have to be motivated to write eBPF, because I spend like countless hours debugging my eBPF programs. Mm-hmm. Because as I said, you have like the eBPF verifier, which actually checks your program doesn't have side effects. Mm-hmm. And this one sometimes kicks in like for super strange reasons. And you definitely have to find it. And the additional difficulty I had, I guess, is because I am using the AYA project, which is compiling Rust directly to eBPF bytecode.
Oh, interesting.
And so this is, of course, very interesting because you can write both the userland program and the eBPF program in the same language. Mm-hmm. But the other downside, let's say, is that it goes through an additional to the Rust compiling, let's say, chain, and sometimes it produces like weird stuff, and you need to find out why this happens and fix your code.
Compilers sometimes are weird, yes.
Yeah, and AYA was like kind of in early development when I first used it, and in the beginning was really, really hard to make everything work. I mean, this was a combo of me being completely new to eBPF, AYA being like new too, and some features were not there, and it was really, really hard in the beginning.
What is debugging eBPF in particular with this kind of Rust toolchain? What does debugging look like? Can you run it in VS Code and hit F5 and single step through it to see what's going on, or because it's running in kernel land, is that just not an option?
No way. No, I mean, maybe there is something that exists. I guess I've seen some projects, some kind of emulating the eBPF bytecode and so on. Mm-hmm. But most of the time what you get is that you try to load your program in the kernel, and then it like provides you a huge, it's not a stack trace, it's basically the instructions that have been executed by the VM, mm-hmm. and then you see where it fails. And then, just you analyze this and you figure out where the issue is.
I imagine you do lots and lots of adding the whatever the BPF equivalent of printfs. You do a lot of printf debugging with this.
You can.
That's what my debugging sessions tend to look like.
Yeah, that's what happens all the time. It's called
So
BPF print K.
yes, I am. I'm concluding that we need an eBPF debugger in the kernel. Let's get on that, guys. Fun stuff. Okay, so one of the things that we've seen sort of in the security world that maybe ties into this that's interesting is security appliances being the target of, and this obviously is when you're talking more about nation state actors and not people just trying to mine for Bitcoin. But actual security appliances being the target where someone will find a way to, say a VPN box that's sitting on the edge of a network. Well, there's an unauthenticated RCE and you can load code onto it. Do you guys kind of have insight into that? And I'm also curious, is there anybody sort of in that space that's maybe looking at running Kunai as part of their security offering?
First, I think that I have a really, really bad news for you. The kernel version used by those appliances are usually very, very old. I don't mention even T or Fortinet. For some of the incidents that we have on those devices, we had kernel that are not actually supporting eBPF. So it would be, I would say, for those kind of operators or vendors, unrealistic to run even a eBPF program. Nevertheless, I would say, and if someone from the vendor space is listening to your stream, I would say it would be a good advice, because then you could stream the log back to CM, for example, from the customer perspective, and they can have a better visibility of what's going on those devices. And I think it's a good point. We were always thinking as this says super hardened appliance box, but if you look carefully, they are not super hardened at all. They are running a Perl program somewhere or an OpenSSL library from the late 90s. So I think there's an opportunity there. The question is, are the vendors creative enough to do that? I'm not sure.
Probably not yet. I very much enjoy reading the Watchtower write-ups on the things that get found in those appliances. And to the vendors' credit, there are a few vendors in particular that have actually stepped up and are trying to fix things and turn on some hardening features and use code that was has been updated since the 90s. But it is quite hilarious to read the things that the cruft that they find in there sometimes.
The blog posts are incredibly good, yeah.
Yes, it is quite entertaining. So what is the oldest kernel that Kunai will run with then?
Yeah, it's not very old. I'm sorry, it would be 5.4 for the moment.
Okay. Well, I mean, we're in the 6 dot. We're in the 6 dot series already, so it's not that bad.
LTS, I guess, is 6.12, something like this.
So nobody, you know what that means? Nobody should be running a kernel too old to run Kunai. Just shouldn't be doing it.
You can do it, but you use ODD for doing such kind of monitoring.
Are people taking the Kunai output and throwing it at LLMs to look for weirdness that you're aware of? Are you doing it yourselves?
I don't personally. I'm super busy on the development, but I know one friend of mine who is throwing the logs into LLMs and generate detection rules, for instance. So yeah, I guess it's something that people are doing.
Yeah, I always found that to be an interesting idea of if you can get a baseline for a system and the normal things that are going to be in the logs and the normal things the processors are going to be doing. And if you have something just smart enough, and we're at the point now where LLMs are just smart enough to do so, where they can look at it and say, something is really different from the baseline. I always thought that was a very interesting like a useful thing, even if it's not malware. It's still useful to know that my system is in a much different state than it's ever been before. Somebody might ought to take a look at this. Sounds like it's a service that somebody could offer.
Maybe.
And if they do it and it's not you, they should share some of their income with the Kunai project. That's a good question. So do you get to work on Kunai professionally? Like, is it your full-time job?
Yes.
How did that come about?
Alex, do you want to?
Yeah, I can explain the
Sure.
funding aspect. So as a CERT, we basically develop open source tools, but the first reason why we develop the tool is for ourselves. So we develop open source tool that will be used by us, and basically we use our own budget to develop those tools. Mm-hmm. The nice thing is, more you develop tools, more you start to have users, and those users want to contribute and fund those projects. And Kunai, for example, is funded through two different streams. One is our own budget, but one is a project called NGSOT, which is an European project for SOC, for Security Operations Center, to basically provide a complete tool set for operating a SOC with open source tooling. And we get funding from the European Commission through the DEP program to work on it. And it's a 3-year project. And we, as CIRCL, we have 3 streams of funding. We have those 2 streams, so that means internal national funding, we have European funding, and then we have private-public partnership funding, which is basically customer. And for some of the open source projects that we operate, we basically have organizations that want to have extensions, things like that, and we get funding out of it. So that's how we fund our project, and we were quite successful on that because we are quite well known on the different tooling that we were doing. And people come to us and say, oh, by the way, we would like to have an extensions. Could we fund a part of it? Or sometimes even people provide in-kind contributions. So for some of the projects that we have even developers paid by companies that are contributing to the open source project directly. So it's very common for the Linux kernel, where you have, for example, people from, I don't know, Intel, Google, whatever, working on the kernel. But it's the same for security space, for security open source tools. We have organizations that are using our tools, want extensions. They sometimes are able to directly fund us, but sometimes they say, okay, we have a good developers. Would you mind to join, or this developer joining your core team for the next 2 years to work on the project? And so that's quite successful. And for the past year that we were doing it, we get, I would say, long-term development, and we get a different stream. So if one of the streams stop, we are able to continue to get funding from those different mechanisms. And that's why we, for example, Quentin was working on this project because he's joined for the European project, but at the same time, he joined the group to develop other tools too. So the team is quite small. So we are in my team, we are 16 persons. So that means we do a lot of things, incident response and software engineering. But we are able to get funding through this different way of funding the project.
And so CIRCL is the incident response team based out of Luxembourg?
Yes.
Very interesting. Okay. I'm curious how part of this works, and that is CVEs. Do you got how? They're both laughing at me. How does it work? Now, there's some history here, and that is that the CVE system is sort of U.S. centric. At least it's based out of the U.S. NIST works with it, and MITRE works with it. Both one is a part of the U.S. government, the other is a weird entity that's halfway U.S. government and halfway private. In the past couple of weeks, there was news that MITRE was going to lose its funding to do the CVEs. So I'm very curious. Like, is CIRCL can you guys assign CVEs? Do you do CVEs at all? Do you have your own system? Like, honestly, I don't know very much about how that works outside of the US.
Okay. So I don't know if you know the backstory, but so we developed a tool called Vulnerability Lookup, which is an open source tool for vulnerability management and CVD process, coordinated vulnerability disclosure process. So we started that project 1 year ago, and this one is a backend software for the European Vulnerability Database, so the EUVD. during that development process, we discovered that we were missing an autonomous way of assigning IDs. So we started a project called GCVE, so it's Global CVE. So if you go to globalcve.eu, it's a project where we basically assign ID. So it's like IANA for assigning ID to organizations that are able to get IDs. Why we did that? We did that some months ago. It was for the vulnerability lookup project. But then with the recent news, we had a lot of discussion at European level. Wait, what should we do there? And then we say, okay, but the model that we developed is backward compatible and forward compatible with the CVE and CNA allocations. So that means us as CIRCL, we can assign CVE as CNA, or we can, as a GNA, assign the CVE, which is kind of global CVE ID. And if later on the CVE ID is assigned, it's fine. So the GCVE project that we started was just in the middle of this crisis from the CVE program. So for us, it was like timing was like a bit strange, but it was perfectly fine. And the European Union, and especially ENISA, which is the agency, so you have to see ENISA like CISA in US, which is the agency for the European Union regarding cybersecurity, did this European vulnerability database, which is no legal requirements for Europe networks. And then we basically provide to them the software backend for that, so vulnerability lookup, which basically plugs to GCVE. So something that we designed as an open source project like more than 1 year ago, like was like more for use case. Now it's growing to, I would say, pan-European use case. So if you're curious, it's vulnerability lookup, it's vulnerability-lookup.org, and you have, it's an open source project again, and we have an online version, so you have all the vulnerabilities, and then we can collide and correlate all the different CVE together. So the timing was like, okay, and now the project is started. The UVD database was like announced just at the same time, just by accident, because technically it was foreseen to be released on February, but that's a long story. Now we as CIRCL, we basically operate that structure called GCVE, where you can ask for an ID, and that's basically it. So even if it's CVE continue to work as program, and that's great, but even if something is going crazy after the 11 months given by CISA with their additional budget, if something goes wrong, no, we are completely independent and we can continue to operate as we wish.
Yeah, and that's only, I would say that's only reasonable that the rest of the world would want to have a way to manage vulnerability, to track vulnerabilities that's not quite so US centric. And I don't say there's a political statement, but just as a general security statement. I think certain news agencies made more out of the funding thing than probably should have been, because apparently this is not the first time this has happened, and
not the first time, exactly.
This guy wasn't falling the last time that MITRE had to figure out how to fund this. But anyway, that's sort of neither here nor there. Looking at the CIRCL website, I do also see something that really fascinates me, and that's the CIRCL passive DNS. What is that?
Oh, that's a long-term project that we have. So the passive DNS is a way to build a directory of all the DNS response that you collect. So the model is the following. You basically put sensors at various places, could be internal sensors and so on, or external sensors, where you collect only the response, the DNS response. So when you query, google.com, you get back a response with the A records, CNAME records, and so on. What we do with the passive DNS, we basically have those sensors, we collect that in a database, and then we have a historical database of all DNS records. What is useful for that? It's useful for threat intelligence. So we get an IP from a, phishing website. We enter that IP and we can find back all domains associated that are related to that IP addresses. We can find back the historical one, first time we see it, last time we saw it. So it's giving a lot of meta information about the domains and so on. So we operate one for the past, I think, more than 10 years now. Our passive DNS is not commercial, so trusted partner can get access to it. So if a SOC, a CERT want to have access, we can give you access. And the passive DNS evolved a bit because, as you know, for example, the TLS standard evolved. So the SNI record in the TLS start to disappear. DNS server node concentrate on, main global DNS provider. So to start to do monitoring for DNS packet and so on is becoming more and more difficult for doing this kind of collections. Nevertheless, we found different ways to do collections on passive DNS. One which is interesting, we operate different services online, Looky-Loo, Pandora, and other things where people can test URLs and so on. But by doing that, this is doing the feeding of the passive DNS collections. Mm-hmm. So if you have someone looking for a phishing website and so on, they do automatically the resolving, and the resolving is going back into their passive DNS. So we have a pretty large database of that information. And for example, if we connect back to Kunai, if we have a malware binary running Kunai doing a DNS request, then we can pivot from the DNS request from Kunai into the passive DNS, finding back the infrastructure of the threat actors, maybe, that is basically hosting different C2 on the different domains. And the passive DNS is really an angular piece to be able to pivot from one place to the other place automatically.
Yeah, absolutely.
And nowadays, I think there's so many passive DNS databases, and passive DNS databases are very localized. Because if you have a passive DNS collection in US, it will be US-centric. If you have one in China, it will be Chinese-centric. So that's something to keep in mind when you do passive DNS usage. Maybe you can query multiple one, and you have a different, I would say, view of the world regarding a DNS request and so on.
Yeah. If a security researcher decided that this would be something that would be useful to get access to and contact you guys, is that a possibility?
Yeah, for sure. We give access to many researchers. Why we don't put it public, it's kind of powerful tool for even reconnaissance, and threat actor might use it for that, and that's why we don't make it completely public.
Yeah, that makes sense. There's been times that I've wished I had access to that. You have a domain name and you're trying to figure out like who are these guys and who did these guys used to be. Well, I can pull their IP address now and do a who is on it, but I'm really curious on 6 months ago what IP address did that resolve to, and let me do a who is on that. And it's very, very useful. I've literally wished for this service to exist before, so I'm glad that it does now. What is the USB sanitizer? Yes, I'm at circle.lu and I'm looking at your services, and this is the other one that I'm not quite sure. What's a USB sanitizer, and how is it different from just running DD over a USB stick?
Well, I can explain the background when it started. So it's even a small story. So we had a representative from the government in Luxembourg going to some countries like China or whatever countries, and they receive USB key from partners. And when you are diplomats and you have a USB key, you somehow need to connect and see what's there.
While at the same time realizing that thing is potentially nuclear radioactive waste that you don't want anywhere close to your computer.
Exactly.
Yes.
And so what we did is it's a software. So we have two versions. One is a library. One is a software running on a Raspberry Pi. How does it work? You basically enter one USB key, which is a suspicious one. You enter a second USB key, and the software inside will start. So you have a little music running. When the music is stopping, the conversion is done. That's super straightforward.
That's great.
So anyone can use it. So the idea is to convert content into some, I would say, payload disinfected content. So for example, if you have a PDF, it's converted into images. You can quickly look into it. And so it's not running with antivirus and stuff like that. Kunai is not running on that one, for example.
Right.
But it could, maybe. But it's actually converting the files into, I would say, less risky files. And then people can have a look at it, unplug the destination keys, and then start to look. And if this Raspberry Pi is compromised, then you can trash it, and that's it. But you basically don't use your computer for doing that. So that's the idea behind. Nevertheless, over the time, I would say the threat model changed a bit. So it was, I think, the USB key was usually a threat models like I would say 5 or 6 years ago. Nowadays, it's not anymore a threat model. So it's one of the open source projects that we still have running. It's still operating, but we don't maintain it quite a lot, I would say, because we have seen an evolution on the threat model regarding USB key, and it's less and less common to actually use USB key in meetings and so on to exchange. But it's still a threat model or threat vector that you need to tackle in some way.
Yeah, if I find a USB key or get one from an untrusted source, I'm not plugging that into one of my computers, not one connected to the network. Do something like this, put it on a Raspberry Pi and spit it out as a text file or something, which is, you guys basically just automated that idea. I imagine it's not so much a threat model anymore because it became so well known as the threat model, particularly after things like Stuxnet. And you have solutions like this one, like the USB sanitizer, that kind of chop the real effectiveness out of it.
Exactly.
Yeah. Very interesting. This is some neat stuff that you guys are doing. Is there another one of these sort of projects that either you're doing that I haven't asked about, or is there anything on the radar for CIRCL?
Yeah, there are many. So maybe one that would be interesting for you. It's called AIL project. So it's ail-project.org. So this project is monitoring dark web. So it's basically a complete crawler for Tor. You have feeder for Telegram channels and so on. We actively use it for monitoring threat actors. It's automatically crawling Tor. You can, for example, do correlations between websites. So you can de-anonymize Tor hidden services. It's a project that we do a lot of work on. We do regular release. And it's actively used by law enforcement, CIRCL, worldwide intelligence agencies. And it's completely open source. Then it could be a dangerous tool because you can actually extract credit card numbers, cryptocurrency, stuff like that. But if you have like good intentions, like CIRCL, Security Operations Center, is a very nice tool for getting insight about what actually threat actors are doing on forums and so on. It's quite advanced tool. So, I mean, Kunai is a recent tool into our different tool set. But AIL project is one of the projects that we maintain and work on. Then I will mention one which is still not public but will be released very soon. It's a rule set with a Z in between, ruleset.org. It's still not online. The idea behind is to basically publish rules from Suricata, Sigma, Zeek, and so on, and to basically use to get the existing one from the different repository. As you know, there are on GitHub plenty of repository with Sigma rules, Sierra rules, and sometimes it's very difficult to find, does it one works well with this detection and so on. And the idea is to be able to have a crowdsourced version of all those different sources, and even authors can claim the ownership on a specific rules. They can review it, they can update it, and then people can download from the website the rule set, and for example, the one at generating not that much false positive, the one that are efficient into this kind of SOC operations and so on. And obviously, one of the rules could be the one from Kunai, obviously. But that's the idea, and we want to do that because we have seen that in MISP a lot of people are sharing information about Yara rules and so on, but we wanted to make it public. So the code base of the software will be again open source, and the web services will be online too. But that's an announce of something new that will be released in the next week.
Very cool. Yeah, that's neat. One more thing on the website I want to ask you about, and that is BGP ranking. The entire idea of attacks against BGP is very fascinating to me, but also a little terrifying because there's not great solutions out there for it yet. And what is BGP? What is CIRCL trying to do to fix the BGP issue?
This one is the oldest and first project of CIRCL. So this one has more than 15 years. We still maintain it. So the project behind is very simple. So we actually get all the BGP announces, and we looked into the malicious list of IP addresses from those different networks announced. So that means we just collect all the announce and we collect all the malicious IP. Then what we do, we summarize to see how long those IP are still malicious in those subnets, and then we rank the ASN numbers based on the proportions of malicious IP of the announced IP. So, for example, if you have like a small /24 and half of those IP addresses, like 128 IP addresses, are always having C2 servers, phishing, and so on, your ranking will be very bad. Nevertheless, if you are a very huge provider and you have like some IP addresses that are malicious and so on, that makes sense. And then you clean up those one and so on, and then you have a low ranking. And on a daily basis, we can compute the ranking of all those ISN. And see, so if you go to bgpranking.circle.lu, you get a top list of the most malicious one. And obviously in the malicious list, you get scanners. That makes sense. But you get a lot of bulletproof hoster that are actually hosting things that they should not host in various places. So it's a nice way to spot the malicious one.
Is anybody doing any automated work with this? Like one of these low-ranked BGP numbers just announced that they're routing half the internet. Maybe we should ignore that.
That's a good point. I've seen 1 or 2 papers that are actually using our dataset, and they were looking at the outliers. So there's some outliers that are interesting. Like they don't announce that much. They are a bit like out of the radars. But why is like that? Is it because they don't host anything? They are just giving access. For example, some obscure VSAT provider tend to be like in the outliers because they just provide access. But sometimes a VSAT provider should have like some malicious IP addresses. You know, you have one compromised machine and so on, it makes sense. But you have VSAT provider with 0 infections over like a period of 5 years. Does it make sense?
Yeah, it's interesting. All right. So, and then let's turn back to Kunai. I have a couple of questions about that before we wrap up. And one of the first ones is, I run a Linux server. Let's say I want to deploy Kunai on it to keep track of things. What's sort of the process to do that? Where can I go to figure out the steps to use Kunai on one of my servers?
So there is a website which is why Kunai rocks. why.kunai.rocks. And basically, it contains all the documentation for you to help you in the deployment of Kunai, in how you can use it for doing really specific monitoring, how to design detection rules, how to load IOCs, and so on. I try to keep this documentation up to date, simple. And again, this documentation is open source. So if anything is missing, just open an issue. I will fix it. And that's it. And I always try to do like the simplest things possible. So cool. I hope the setup is quite simple. Yeah,
it looks really good. Is there anything coming for Kunai that you want to let folks know about?
Yes, there is something that we will put online soon, I guess, which is a platform where you can upload malware samples, and it will get directly analyzed with Kunai in a virtual environment. And why is this interesting is that because when you are doing most of the time incident response, you use sandboxes to execute samples of any sort. But the output of it is most of the time not directly compatible with your detection tool chain. So the idea was to have like directly Kunai logs out of malware monitoring, so that you can directly create detection rules using Kunai. So the platform will not aim at being an additional sandbox, will not aim at defeating anti-malware sandboxing and so on. Will just be something where you throw your malware in and you get the Kunai logs. And that's basically it. It's using a project which is already on GitHub, which is Kunai Sandbox, and basically it's a front end on top of this. And I just released the code past week, so it should be online soon.
Very cool. It saves me from having to stress about setting up an absolutely secure sandbox to be able to do this testing. Very cool. All right. Is there anything that I didn't ask you guys about that you wanted to let folks know about? I know this is a challenge. You got to think through all the things we talked about and all the things you wanted to.
No, just one thing, that we have a conference in Luxembourg called hack.lu in October.
Oh, very cool.
And we still have a CFP open for open source projects. So if you go to hack.lu, you can submit your paper. There are still some day left before the closing of the CFP. So, and we welcome open source projects and especially open source security projects there.
Very cool. I'm curious, and again, this is a question, very much an American-centric question. What about the language there? Is that going to be a French conference or English? And if it's in French and someone comes like me that doesn't speak French, am I just going to be completely lost, or is there helps? How does that work?
So Luxembourg, we have officially 4 languages. So Luxembourgish is one, French, German. And one of the most spoken language in Luxembourg is Portuguese too, because we have a huge Portuguese community. But the conference hack.lu, it's obviously English or broken English depending of your origin. But technically, it's an English conference. So we need to do a conference where everyone is welcome. So that's usually the universal language.
Yes. Very good. All right. Appreciate that answer. Okay. So I'm being reminded now in our chat room, I forgot this last week. I want to ask each of you guys, and we'll start with Quentin. What is your favorite text editor and scripting language?
A scripting language. Yeah, it's Bash.
It's Bash.
And text editor, I would say Vim.
Bash and Vim. Makes sense. Alexandre?
So obviously Vim, I was a long time Emacs user, and then one day my head hit the toilets, and then I changed back to Vim. I think we are the only 2 Vim users at the office, Quentin, I think.
Really? Funny.
Yeah, I think the rest is more like more IDE one. Scripting language. I'm a long-time CPAN contributor, so I really like Perl for years. Even if I would say Perl is not even a scripting language, it's much more than that. It's a philosophy. But indeed, for me, Bash is still a great way to do quick scripting and so on. But I would say Perl, Python are my favorite in scripting language.
Yeah, very good. All right. Thank you guys so much for being here. It's been a blast learning about Kunai and all the things CIRCL is up to. I appreciate it. Once some of these things come to fruition, after a while, we'll have to have you guys back and talk about what's changed in the landscape of Linux threats.
Thank you very much.
Thank you.
All right. That was a lot of fun diving in and talking about some of those things. I cover a lot of these on the security column, and it's neat to be able to talk to some of the people on the front line about things that are actually going on. I very much enjoy that. All right. So I want to let folks remind you that if you want more of me, there is, of course, the security column. It goes live every Friday morning on Hackaday. There's also the Untitled Linux Show over at Twit. Make sure and check that out. We will be back next week with another episode. We sure appreciate everybody that's here, those that listen and those that watch, both live and on the download, and we will see you next week on FLOSS Weekly.